you anywhere. Closer to me. Where you I will be.
Hey y'all, so I received a few questions about the second half of your problem set 2 for this week. So I just want to take a moment to highlight these types of questions. When you're given an equation that looks like this and it's asking you to complete the equation, so you're given like 2x plus 7 equals blank, it's asking you to come up with the second half of the equation. You get to make this part up. I'm not going to say there are no right answers, but there are infinite amount of right answers. Not to confuse with their infinite amount of solutions. So if I'm given this problem, 2x plus 7, and it's asking me to fill in the blank in order to find one solution for x, I'm going to make up something to go on that right side of the equation. So let's say I'm going to put in just 8. So I want to make sure that 2x plus 7 equals 8. Now, I've completed the equation. However, I have not solved for x. I don't know what my one solution is. In order to do this, I need to take my new equation, 2x plus 7 equals 8, and get all my variables to the left and all my constants to the right. I've already gotten all my variables to the left. I started out with that. That's purposely why I wrote the equation like this. I knew that would eliminate a step for me. But I still need to get all my constants to the right. So I need to get this plus 7 over to the right hand side, and I'm going to do that right now. So when I did that, I was left with 2x equals 1. However, my x is not by itself. It still has that pesky 2 right next to it. So I need to get rid of that 2 by dividing by my coefficient. Remember, a coefficient is my number that's next to the variable. So I'm going to divide by 2 on both the left side and the right side right now. When I divided by 2 on both sides, I was left with x equals 1/2. This gives me my one solution, my one answer, my one number that x can equal to make this statement true. And that one solution is x equals 1/2. We're now going to go back and redo this entire problem starting with the original prompt, but instead of completing it for one solution, we're going to complete it for no solution. So as you see, I started with the original prompt, 2x plus 7, but instead of writing 8 in that blank, I now wrote 2 times the quantity of x plus 3. Now remember, my goal is to get all my variables to one side, all my constants to the other, so I can solve for x. In order to do this in this problem though, I need to get rid of the parentheses by using distribution, which is what we talked about last week. So I'm going to do that right now. So I went through and used distribution in my problem. I got the new problem, or just an equivalent expression if you will, 2x plus 7 equals 2x plus 6. Now my goal, unlike any other problem, or I should say like any other problem, is to get all my variables to one side and all my constants to the other. In order to do this, I'm going to subtract by 2x on both sides to move by 2x from the right to the left. Now, if you notice, my x's actually canceled out. They're gone, there are no more x's. So my x really can't equal anything. And I've also been left with 2 different constants. I have a constant 7 and a constant 6. And my equal sign is saying that they mean the same thing. Now, we should know this from elementary school, but 7 does not equal 6. 7 equals 7 and 6 equals 6. This is a lie, meaning that there is no solution to this problem. So if you were asked to complete this equation, so there's no solution, this would be a viable answer. When I put in 2 times the quantity x plus 3, I was left with a lie, meaning that there is no number for x that would make this original equation true. Now I'm going to go back to the original problem, and this time I'm going to find infinite solutions. Now I have the equation 2x plus 7 equals the quantity of 2x plus 2 times 2 plus 3. My goal, just like we've been doing, get all my variables to the left, all my variables to the right. And just like the last time, I have parentheses that I need to get rid of first. So I'm going to do that right now. So now I have 2x plus 7 equals 2x plus 4 plus 3. I have like terms right here. I can combine these because these are both constants on the same side of the equal sign. Remember, just like when we divide our equal sign, anything that's on the same side that is the same type of term, we can put together. So I'm going to add my 4 and my 3. I'm going to do that right now. So you might see something special here. And if you see it and you remember what I said in last week's video, hold on to that. But I'm going to keep solving this problem just like we would any other problem. Get all my variables to the left, all my constants to the right. So I'm going to get rid of this 2x by subtracting 2x on both sides. Now this might look somewhat like last problem, but a little different. Instead of getting 7 equals 6, I have 7 equals 7. And like we said, 7 equals 7 and 7 will always equal 7. Because I was left with this is what we know as a truth. Meaning I'm going to have infinite solutions. No matter what number I plug in for x, I'm going to have infinite solutions. I hope that this helped out a little bit this week. Try the problems. Make sure you do your Mathia first. Your Mathia should be done before you even touch Google Classroom. If I get both of them done, I need 3 Mathia assignments done a week, and I need all your problem sets done each week. Good luck.